Hi guys, what's up? In this video, we are going to be reviewing arc length. All right, so this is what we did last week. Remember, all of this is just going to be straight up formula work. All right, so we are given circle C and we want to find the length of arc AB. All right, remember, arc length and arc measure, two different things. Arc measure is going to equal that central angle, right? And they are congruent. So this measure would be 45 degrees, but what we want the length. So we're going to have to use our handy dandy formula that's right up there. Okay. So, gosh, ignore my voice. Sorry. Our first step, we need to identify our radius, which is the line from any point in the center of our circle to the edge. So that's our radius. That's our radius. You can have like a million radii in your circle, okay? So it's just from the center to the edge, right? So our radius is going to be 12, and then our theta is our central angle. Again, you might see that sometimes written as alpha. Same thing, don't freak out, it's just Greek, right? So we are going to plug into our formula, all right? So we have 2 pi. Our radius is 12, our theta is 45. Divide that by 360, all right, just to follow where everything came from. There's our theta, there's our radius. These other pieces, straight formula, okay? So we head to handy dandy Desmos, and you can put it in exactly as is. So I'll start my fraction. 2, to put in pi, you literally type P-I. Right? 12 times 45 up top. On the bottom, 360. All right, so that tells us that our arc length equals, approximately, remember, because we have a decimal, we're rounding, approximately 9.4. Okay, approximately 9.4. All right, next one. Same thing. We're going to come out here. We're going to identify the radius. Our radius is 12. This time our theta is 60. All right, so we plug that into our formula. We have 2 times pi times 12 times 60. Divide that by 360. And here's the nice thing about Desmos. It saves where you were. So we had the same radius in that last problem. All I'm going to do, replace that 45 with 60. Boom. There is our new approximate arc length. It's approximately 12.6. Okay. These next ones are going to be a little trickier because we are going to work backwards. All right. This time we are given the arc length and our radius, but we want to find our theta. All right, so our arc length is 10, our radius is 6, and we're going to work backwards. 10 equals 2 times pi times 6 times theta divided by 360. The way that we undo dividing by 360 is we multiply both sides by 360. That goes away. So we have 3,600 on the left. On the right, we can multiply these things together. 2 times 6 gives me 12, and just leave that as pi. Do not use 3.14. All right, always, always, always leave that as pi, and you can treat pi like a number, right? Because pi represents a number that just goes on forever and ever and ever and ever and ever. All right. To undo multiplying by 12 pi, all we're going to do, divide by 12 pi on both sides. Okay? Again, you're going to head over to Desmos and plug, let me circle this in. This is where we go to Desmos, right here. All right? So in Desmos, let me move my screen. We have 3,600 divided by 12 pi That tells us that our angle, our theta, is about 95.5 degrees. Okay, all about just using that formula and working backwards. I'm going to do one more working backwards example. All right, this time, let me move my screen again. A circle has an arc that measures 80. Arc length is 274. What is the radius? All right, remember what we actually just talked about at the beginning. Arc measure is identical, it's congruent to our central angle. Okay, so again, we're solving backwards, this time for radius. So our arc length, 274.46 equals 2 times pi times r times 80 divided by 360. To get rid of dividing by 360, we're going to multiply by 360 on both sides. Okay, this one, honestly, like I'm not going to simplify this. Like I'm just going to keep rewriting it as is because these are some big numbers and you can put them into Desmos. Okay, so we'd be multiplying these terms. On the left, I want to multiply 2 and the 80. That gives me 160 pi times r. Again, now it's time to just go ahead and divide by 160 pi from both sides. And this is the exact step you'll put into Desmos. All right. And when you do that, we'll figure out approximately what our radius is. Okay. So we had 360 times 274.46. All of that divided by 160 pi. Oh, that is a hefty radius. Okay, but this is telling us that our radius is approximately 196.6. And if you look at the original problem, it gave us, where'd it go? There we go. Our unit, it gave us inches. Okay, so approximately 196.6 inches. Okay, hopefully this helped with arc length.